The next piece of our puzzle talks about complementary angles. Remember what complementary angles are. So we can say angle A and angle B are complementary. Or sometimes we say they are complements of each other. They are complements. They are complementary. If, what's the rule? What's required for complementary? Which one is complementary? Which one's supplementary? Which one is 180? Which one is 90? 90. Well, which one is complementary? Remember, it's alphabetical. Complementary comes before supplementary, and the numbers 90 comes before 180. 90. And so, angles are complementary if, in this case, angle A plus angle B is equal to 90 degrees. So what does that have to mean? Well, look at this. Consider any right triangle. Any right triangle. Let's call this C. It doesn't matter which. Let's call this A. Let's call this B. In any right triangle, the two acute angles are complementary. In any right triangle, we know the two acute angles must be complementary. Is it clear why? Is it clear that if you add all three angles together, the total must be 180? We know angle A plus angle B plus angle C must total 180 degrees. But we already know C because we are requiring this to be a right triangle. So if we have a right triangle, that requires that this must be known to be 90 degrees. 90. So what we're saying is angle A plus angle B plus 90 is equal to 180, which means this is the key result. This is the key result. Look, see, we see that. So what this forces angle A plus angle B to equal, subtract this to the other side of the equation. What's that total? That total is 90. And so angle A plus angle B is always equal to 90 degrees. 90. And so that means that in any right triangle, in any right triangle, the two acute angles are complementary. In any right triangle, the two acute angles are complementary. In any right triangle, the two acute angles are complementary. All right? Now, how do we play with that? Where does that come into the mix of what we're working with our function values? Because of this, and because we know SOHCAHTOA, we can establish some basic rules and some basic properties that are always the case. All right? So, consider any right triangle. Let's call it, it can be in any order here. I'm going to put here, there. I'm just going to make any right triangle. It can be any orientation we like. Right triangle. Let's get off the ABC schneid. Let's call this PQR. All right, PQR. And let's call this angle Q. Let's call this angle R. All right. So what do we know? What do we know about angle R? All right. What do we know about angle R? Well, what is, for example, what is sine of angle R? What is sine of angle R? Well, let's label the triangle here, right? Let's call this lowercase r. Let's call this lowercase p. Let's call this lowercase q. Right? The side opposite is the angle. So this is lowercase q, this is lowercase r, this is lowercase p. What is sine of r? Sine of r, right? From the perspective of this angle r, this is the hypotenuse, this is the opposite, this is the adjacent. So sine of r is whatever is opposite r, which is lowercase r, over hypotenuse, which is lowercase p. So we know sine of r is lowercase r over p. I've just chosen p, q, and r at random. The letters are irrelevant which ones we pick. But now, consider now cosine, not of r, but consider cosine of q. Consider cosine of the opposite angle. Not the other angle. Here's r, this is q. What is q? Q, cosine of q, from the perspective of q, this is still the hypotenuse, this is the adjacent, this is the opposite. And what do we know about cosine, SOHCAHTOA? Right? We know that cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Cosine is adjacent, which side is adjacent to angle Q? Little r. Little r is adjacent to angle Q. Over hypotenuse. Hypotenuse is known to be lowercase p. But look, those are the same. Therefore, sine of r is equal to cosine of q. Sine of angle r is equal to cosine of angle q. Now, one other piece of the puzzle, we've already talked about this. What do we know about angle r and angle q? What do we know about what they add up to? Is it clear that angle r and angle q are complements? Angle r and angle q are complements. Now, sine of r and sine of q are not equal. They're not. But sine of r and cosine of q, they are equal, and that is not a coincidence. That will always occur. In any right triangle, that will always occur. These sine and cosine, you will have noticed the names. Sine, cosine. Tangent, cotangent. Secant, cosecant. Those are called cofunctions. Sine and cosine are cofunctions of each other. It's in the same spirit. It's not the same thing, but it's in the same spirit as negative and negative. But it's not that same thing. Sine and cosine are cofunctions of each other. Tangent and cotangent are cofunctions of each other. Secant and cosecant are cofunctions of each other. And so what this says is, if you take cofunctions of complementary angles, cofunctions of complements, right? Cofunctions of complements. Let's eliminate the middleman. Cofunctions of complements are equal. 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 Now, it turns out we can check this out if you know how to use a calculator. If you can find the trigonometric functions on your calculator. So for this next little demonstration, what I'm going to do is assume you can use a calculator. I'm going to assume you can use a calculator. It doesn't need to be a graphing calculator. Any standard scientific calculator that has the trigonometric functions. Anything you used in college algebra or in an algebra course, anything you used anywhere that you found, for example, logarithms or anything else on, that's more than sufficient. So I'm going to use this calculator because it's the one I pilfered from the school. I didn't pilfer it from the school. I'm using it because it's here. Here it is. I'm using it. So make sure that your machine is in degree mode. Degree, not radians. Degrees, not radians. If you need to know how to make your calculator be into degree mode, not radian mode, then there's this new thing called the internet, and you can do a Google search on your calculator. It'll tell you how to change from degrees to radians and back and forth. So make sure you're in degree mode. I am in degree mode, so I'm in degree mode. So we can illustrate this property now with our calculator thing, with our calculator computations here. So pick any acute angle you want to find. Any acute angle. Sine of, let's say, pick a number out of the blue sky. Sine of 20. If you take the cofunction, and I want the complement of 20. What is the complement of 20? What's complement of 20? Complement of 20 is 70. And where did that come from? That came from 90 minus 20. 90. So sine, I need to put my degree symbol. Sine of 70 degrees, cosine of 70 degrees. If you find those two numbers on your calculator, they stinking better be the same number. They need to be exactly the same number. And with my machine, because I have a display screen, I can actually maintain them. So if I do sine of 20, that is 0.342020, blah, 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 blah. 0.342020, yada, yada, yada. If I do cosine of 70, that better give me the same number. Otherwise, I just spent a whole bunch of time telling you something that's false. It is the same thing, 0.342020, blah, 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 blah. All right? So they are equal. Now, again, where did the 70 come from? Where did the 70 come from? That was 90 minus 20. All right? There's nothing magic about 20. And you don't need to start with sine. You can start with cosine. Cosine of, pick a number out of the blue sky, 52. Cosine of 52 degrees. If I told you correctly, that should equal, what should this equal? What should this equal? Without using a calculator, without what we should, well, we might have to use for the subtraction. Sine of, what number should go in here? And more importantly than what number is, how do you find it? If I take 90 minus 52, I get 38 degrees. Those better equal each other because they are cofunctions of complements. Let's see if they equal each other. It's thinking better be, otherwise something's wrong somewhere. So if I do cosine of 52, I have 0.6156 blah, blah, blah. And if I do sine of 38 degrees, I get 0.61566 blah, blah, blah. So yes, these are in fact correct. That doesn't prove anything, but it sort of serves to solidify your notion that these are in fact the same thing. Now, where did the 38 come from? It came from here. It came from, this is sine of 90 minus 52. There's nothing magic about 20. There's nothing magic about 52. There's nothing magic about 38. This works with any acute angle. It must be an acute angle. For our purposes, it must be an acute angle. So we generate these properties. We generate these properties. Sine of theta is equal to cosine of, when this was 20, we needed 90 minus 20. When this was 58, or 52, we needed 90 minus 52. So what do we need? If this is a generic value theta, then we need 90 minus theta degrees. Sine of theta is equal to cosine of 90 minus theta, and vice versa. If you start with cosine here, then you have sine over here, and vice versa. Now, it's easy to check with sine and cosine because you have a sine and cosine button on your calculator. The others are also true. It's less easy to verify with the machine, but they are in fact the same. By the same argument, by the same principle, we also have tangent of theta is equal to, what's the cofunction of tangent? Cofunction is the cofunction. Cotangent is the cofunction of tangent. And vice versa. If cotangent is here, then tangent is here. And the last is secant of theta is equal to cosecant of 90 minus theta. And vice versa. Now, one place, there are several places this comes into play. But one place this might come into play is this. Suppose you need, for a reason we don't know how, we don't want, this is one way this might come into play. This is one convenient way to work with this. Suppose we want cotangent of 40 degrees. Suppose for whatever reason we're working on some project and we need cotangent of 40 degrees. Well, the problem is, calculator doesn't have a cotangent button. There are many ways to do this. This is one way. One way to do this is use this property. We know if I do cotangent of 40 degrees, that must equal tangent of, you tell me, what value do I use there? It needs to be the complement, 90 minus, so that's tangent of 50 degrees. And so if you find tangent of 50 degrees, that will give you, excuse me, if you find tangent of 50 degrees, that will give you the value of cotangent that you want to have. There are other ways to do this as well, but this is one way to find that value, and there are other places where these properties come into play. For our purposes now, these are three. Actually, there are three more, because you could put cosine over here and sine over here. It's the same property. You put cosine over here and tangent over here. It's the same property. So it's these three properties and vice versa. Cofunctions of complements are equal. Cofunctions of complements are equal. Cofunctions of complements are equal.